There's the beef. Well, we are going to be looking today at vector addition. Vectors you're already familiar with, or I hope you're already familiar with. And the reason why we're going to be talking vector addition is because we are fast approaching projectile motion, which is either going to be your favorite thing in the world or it's going to be your least favorite thing in the world. There's really not much middle ground in between. But to understand projectile motions, we're going to need to dip our toes back into vectors, and we're going to be learning today how to add vectors to find something called a resultant, both by using algebra and by using geometry. So, you get to use both brains with this today. First of all, just to recap on what a vector is. You know what a vector is. Can somebody tell me what a vector is?
It's a quantity with direction.
Quantity with direction. Excellent. Okay. Vectors have both direction and magnitude, right? We represent a vector when we're graphing it as a line segment with an arrow on it. Okay, so it's a line segment with direction. So when we graph it out, its magnitude is symbolized by the length of the line segment, and its direction is symbolized by the point of the arrow. And we can give the direction an angle if we set our x-axis, our positive x-axis, as a starting point. So we've got 4 different vectors right here. My question is, which vector there has the greatest magnitude? The first one, right? This fellow right here. How would you describe this second vector right here? Okay, so it's heading at a negative angle, right? So nothing really strange there. Vectors, you're going to need to know some terminology here. The initial point, or the tail of the vector, that's where the vector starts. The terminal point, or the head, is the pointy part. Now here's the important part, and here's where we're going to start to tie it into projectile motion. If you have a vector, it has got, since it's something that is graphable, it's a graphable line segment, it has what's called an x component and a y component. And so you can record any vector using just a pair of digits, okay, if you know the origin point. And just like you would write out coordinates, x, y coordinates, we write out x, y components, but instead of using parentheses, we use pointy brackets. Okay? So for instance, looking at this vector right here, how would you notate this? Yeah, start with your x and count over how many spaces your x goes. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be positive 9 because it's going to the right. And your y component would be 1, 2, 3, 4, 5, 6. So positive 6 because it's going up.
So it'd be 96.
And point the bracket, that's exactly right. If we were to get the notation for this, the x is positive 9. The y is positive 6. So you note it like that. Okay, so take a look at these right here, and let's look at vector A first. What would its vector notation be? Okay. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. 2. Okay, so this would be positive 8 and 3. I did it too. And then the pointy brackets. How about vector B?
Positive 5, positive 4.
Darius, you know this is 0, right?
Yeah.
Okay.
I just, no.
All right, 1, 2, 3, 4, 4,
Positive 3.
3. Okay. Let's see if our little check button works. Yeah. 8, -2, and then 4, 3. Cool. Questions there? So, if you have 2 points, like you have a starting point and an ending point, then you can get the component form of that vector by taking its terminal points minus its starting points, and you do the x's separately from the y's. It's very, very similar to finding like the slope of a line. Okay. So for t, that would be the terminal point. You've got x and y. Now notice that these are curvy, right? Because this is not the vector, these are the points. So for your ending point, which is x sub t, y sub t, and your starting point, which is x sub I, y sub I. So again, it's going to be terminal minus initial for each of those. So you do xt minus xi, you get your x component, and you do yt minus yi to get your y component. Just like that. And then those will go in pointy brackets because that will give you the notation for the vector. Now here's a big important concept, and I'm going to go ahead and just like write here because this is super duper important. And very, very important. Anything going on with the x, you keep separate from anything going on with the y. The x has no effect on the y, and the y has no effect on the x. That was very loud. It's kind of loud and crinkly, yeah. That's fine. See how good the microphone is if it picks up your pop truck crinkle. So, how about y'all take just a minute and see if you can work this one out. Find me the component form of a vector starting at -4, 3 and terminating at 8, -7. So these are your t's, these are your i's. Okay, yeah, work it out for me. I know perfect. So to find your x, you're taking 8 minus -4, right? What is 8 minus -4?
12.
That's positive 12, right? What is -7 minus 3?
Negative.
-10.
Good job.
So in other words, if I was to draw this out, it's got a positive x, which tells me that it's going to be going that direction. It's got a negative y, which tells me it's going to be going that direction. So in other words, the entire thing would be going more or less in that direction. Okay? All make sense? Okay.
So it's basically like finding slope, except you're putting those numbers in one point instead of dividing them. Okay. That makes sense.
So, what if you've got multiple vectors? And I want to show you, kind of for example, what I'm talking about here. Let's say that I've got these 3 vectors right here. And I want to figure out, okay, well, if I've got all 3 of these force vectors acting on a single object, what is its resultant vector going to be? How or where is it going to end up? What direction is it going to end up pointing? So here's where we're getting into the new stuff. 2 ways to do this. Okay? Whenever we do them geometrically, we're going to link them all together. Head to tail, head to tail, head to tail. Okay? Let me show you what that looks like. Let's say that I've got vector W and I've got vector V. Okay? So if I want to find a resultant vector which is equal to W plus 2V, I take my W, and right there at its terminal point, I stick the initial point of a V, and then right at the end of its terminal point, I stick the initial point of another V. And my resultant vector actually starts with the original starting point and ends with the last terminal point. Okay?
Question.
Shoot.
How do you know which direction to point to be?
How do you know which direction the...
To point to be? Or is it like...
Well, keep in mind, each of these has an X and Y component, right?
Yeah.
Okay? So the V, I don't know what the numbers are going to be, but it would have a positive X and it would have a positive Y. Because the X is going this way, the Y is going this way. So we know it would be pointing that way.
Okay, but how do you know it's like that angle and stuff, you know? Like how do you know
Because-
it's not higher up?
Okay, because if I back up the slides, same way that you know that that's going to be at a specific angle because it goes 4 over and 3 up.
Okay.
Okay.
Well, I thought we didn't know those numbers yet.
What do you mean?
The X and Y components of the Z, I thought we didn't know those yet. That's what we were solving for.
You mean the X and Y components of these dudes here?
Yeah. I
Okay.
thought that's what we were solving for.
Right now I haven't put numbers to them.
Okay.
Okay? All that I'm showing you is that geometrically you can find the resultant by sticking them all together.
Okay.
This is going to come in a lot more handy when we get to the algebraic part where we are doing things with numbers. This is why the numbers work. Okay? Just bear with for a little bit, and if it still doesn't make sense in a while, then I'll come back and try and re-explain it. Okay. Good place for questions. Anybody else have one? Let's try it. Okay. So we're going to do 2V plus 3U, and I'd like a volunteer to step forward, or I can popsicle stick one.
Popsicle stick.
Let's do that.
I love this one.
Love the sticks.
I love it so much it's gonna kick me face.
You love them so much, how about you marry a stick or something? Okay. Alexis Thompson, come on down.
That would be cool if I did.
Alexis, I would like for you to show us 2V plus 3U. So start by pulling down a V. Okay. Get another one and put it head to tail with the first one. Yep. And then 3U. So drag down 3 of those, and we're going to start with that one right there. Oh, hold up. Let me see if I can. Yeah, just a sec. Let me control Z out of that a little bit. Yep. Okay, great. I think so. Okay. Grabbing a couple more. Now use a marker and draw me a resultant. Start at your original starting point and end up at your final ending point. Okay. Right, and label it R. Okay. And that's exactly right. We can actually check the solution and see how exactly right it is. Oh, look at that. That is textbook. Way to go, Alexis. Give her a hand now. Fantastic. All right. Any questions with that? You see how we did it?
Yeah.
Okay. What is the extension? Drag your resultant vector on top of the solution resultant. What do you notice? I don't know. What do you notice? That is basically the same thing. Exactly right.
You notice we're pretty good at this stuff.
Yes, she is. Let's try another one. Let's represent negative 4U plus W. So how would I go negative u?
I have to.
Jasmine, how much come up with this? Okay, so I'm going to give you a little hint here. How about you tell me real quick in concept how you would represent negative 4u?
Yeah, I was thinking like maybe go that way, but I don't want to help with that way more negative, so.
Well, keep in mind, when we're talking about like motion and forces and things like that, negative simply indicates the opposite of flight. So if that's u, check this guys out. Which one? Oh, look. Now, let me set this up real quick. Boom. Okay. So here is your negative u. All right, go for it. 1, 2, 3, 4. Okay. Plus w. All right. Now, draw me a resultant vector. Starting at the end. And put an arrow on it. Okay. And let's here. Grab the solution and pull it over. Let's see how you did. Check it out. Gorgeous. Excellent job. Nice one. Okay.
Very proud.
Again, this is a great place to ask a question if you got one. So that's geometric vector addition. Oh, by the way, if we didn't really talk about it, resultant, you may or may not have got it in passing. If we were to write a definition for resultant, how would you define that?
The answer.
It's like whenever we would draw like tangent lines, but
Okay.
it's not a tangent line, but it's similar to that
Okay.
sort of.
It's kind of a way to, if you've got several things happening, it's a way to sort of summarize big picture of what's happening. Okay, great. Right.
Basically.
Yeah, so resultant has the word result in it, right?
Yes.
So the resultant would be the sum of all your vectors. If all those vectors happen, this is the result. Keep in mind, forces are vectors. The forces have both direction and magnitude. Also keep in mind, what happens in the x does not affect what happens in the y. Okay, moving on. Let's look at the algebra side. Nope. Actually, before you do that, I would like you all to write me a vector equation for this.
Oh, what now?
A vector equation. Okay, like a minute ago, the vector equation for this one was negative 4u plus w. Write me an equation there. Start with where the starting point is. Starting with the v's or the u's or the w? How many are there? Okay, so you're starting out with 2v.
Plus.
Going in the same direction. Plus.
2w. No.
Hey, can I blow your mind again?
Yeah.
It doesn't, because it's addition, you know when you add things, it doesn't matter if it's plus 3 or 3 plus 2. It doesn't matter what order I put those vectors in, I'm still going to get the same result.
Cow.
Fine. Let's try doing from the same starting point. Let's do a U. Let's do a V. Let's do another U. Let's do a W. Now what do we still need? We still need another U and another V.
We need 2 U's and a V.
We've already got 2 U's.
Oh, we need another V.
I just need one more.
Well, I'll be. Well.
Make sense?
Yes.
Okay. You know, another way to think about it, if you're playing chess and you're moving the knight, does it matter if you go up 2 and over 1 or up 1 and, or over 1 and then up 2?
You go,
You're
you
gonna
go
get the same place,
spot.
right? Same thing with vector addition.
You got it.
Now, they're still having us do geometry. Fine. So use the vectors to geometrically represent u plus 3b plus w. Geometrically represent the equation and state the component for the resultant vector. All right. So first of all, let's have Emma come up and build that for us.
Let's go, Emma.
U plus 3b plus w. Bless you.
Does it matter where I put it?
I would just say start it on some kind of a junction point where we can definitely tell. Yeah, that's fine. Okay, plus 3b. Maybe so. That's fine. Oh crap, come on. But I think you did, and I think the camera will show us that you totally did.
So speaking of things making noises, I heard Devin tried to fire back on you the other day, Mr. King.
Yeah, he tried. He was woefully unprepared.
He said that he fired and then he pulled out a drawer full of darts and he was not prepared for that.
That's right. Huh?
Alright.
I don't know. Does that look right to you? It's u plus 3b plus w. So draw me a resultant. Use your black marker. All right. Gorgeous.
It looks like a velocity line.
All right. So before we check the answer on this, let's talk about a few things. Let's first of all see if we can figure out algebraically what each of these vectors are. What would u be? It's got a positive x, right?
Yes,
How many?
5.
Okay.
-2.
And negative.
-2. All right. Okay. How about z? How about z? Okay. What is z?
1,
Z
2.
Okay. So it's +1, +2. Agreed? And how about w?
2, -3.
Okay, that's going to be 2, -3. I like it. Everyone else agree?
Yes.
So, if we're adding these vectors up, okay, let's start by looking at all of the x's that we're going to be adding. Okay? So we've got 5 plus 1 plus 1 plus 1 plus 2. So that's 5, 6, 7, 8, 9, 10. With me? No, I think I did. Sure I did. Okay. Now let's look at all of our y's. I've got -2, +2, +2, +2, -3. Okay, so -2 plus -3 is -5, right?
Yes.
Yeah.
-5 plus +6 is what?
1.
+1.
Oh.
Let's take a look here at our resultants. It goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And it goes, if we're ending it right there, it goes up 1. Take a look. So that's how you algebraically find the resultant for your vectors. You add all the x's up, and keep in mind, some are going to be negative, some are going to be positive. You do the same thing for all your y's. Now let's see if our answer is in fact 10, 1. Look at that. Questions?
Good job.
It's a great place for one if you got one. So let's combine, okay. Combining vectors algebraically. So if I've got 3 of this particular vector. So this vector right here, it would be +4, -2, so it would go over like 4 and it would go down 2. So it's going to be like that, right?
Yeah.
Okay?
There's 3 of them.
And if I've got 3 of them, then you can distribute it. If I've got 3 of them, it's 3 times 4, which gives me 12. It's 3 times -2, which gives me -6. Okay? Nothing difficult there, right? Now, what if I wanted to combine 3 of this vector plus 1 of that vector? 3 times 4 is 12, right? 12 plus 5? 17, okay. And I've got 3 times negative 2, that's negative 6. Negative 6 plus positive 4? Negative 2. Okay. So negative 6 plus 5, 4. I decided that comes to 17, negative 2. So let's say that I've got these. Now here, we could find the resultant in a couple of different ways, right? Let me see if I can make a copy of this slide real quick. Maybe? Will you not? Well, on the page. Okay. So, one way I could combine these three is I could actually physically move them around, right? Especially if they're not locked down, they're not. Okay. So there's 1, 2, 3, which means that my resultant on this one is going to start right here, and it's going to go right there. Everybody cool with that? Yeah. But what if I want to find algebraically what the resultant is? What am I going to need to know for each of these vectors?
The slope.
Well, I'm going to need to know the x and the y, right? Now, this one's going to be really easy to find, okay? What is my x on this one?
6.
0.
Oh.
Negative 6.
Negative 60.
Oh.
What's my y?
0.
There you go. Well, what about these dudes right here? All I have right here is a quantity and an angle. How can I find my x and y with that?
Because they were in 0. I didn't say that.
You can use the angles on like the.
Exactly, it's the, yeah.
Uh-huh.
Let's go.
X. So we can trig to find those.
Yeah, I like you.
Well, let's trig to find those. Okay. So check it out. If that angle's 20, what angle is this?
80, 60, 70. What
Yeah,
is wrong
somewhere there,
with
you're right.
What's wrong with you?
Which also means that this angle down here is 20, right?
Yes.
Okay, which makes sense because these are parallel and this is bisecting, so those alternate interior angles are congruent. Okay, I like geometry. So, right, so if we're, this is opposite over hypotenuse. So, hey, so sine of 70 equals x over 100, right?
Yes.
Cool. Cosine of 70 equals y over 100. Okay? I'm not going to crunch those just yet, but we'll come back to them. Let's go look at our blue one. Our blue one, here's our triangle, here's our x, here's our y, and our hypotenuse is 80. Okay? So if we were to say sine of 65 is going to be y over 80, and cosine of 65 equals x over 80, that's an x, then we can get x and y components for each of these vectors, right? So I'll let you get yours.
Yes.
Okay. So what's your x for your green?
I got 93.96.
Okay. Let's make it 94. Just to make it easy. So our x is 10, which is 94. Okay. Emma, have you got our y yet?
34.2.
34.2. Let's just call it 34. Now it's going to be negative 34 because we're going down, right? So y here is going to be 34. So my vector for this one is going to be 94, negative 34. Okay. Gentlemen working on the blue triangle. Ruth, you got an x for me?
I got
33.8. Let's call it 34 then. Okay, so your x is 34. Darius, you got a y?
Yeah.
What you got?
72.5.
72.5. We'll call it 73. And it's positive because it's going up, right? Okay. So let's see what happens when we add all of our x's. What is 94 plus 34 plus negative 60? Positive 68. Somebody confirm?
Yes.
I got positive 68.
All right. So Okay. Aye. Okay.
How'd you ditch it anyways?
I didn't, it was like that when I got here.
Oh,
Let's add up our y's. What is negative 34 plus 73 plus 0?
39.
Positive 39?
1 second, let me check.
Can you confirm that?
4.
Yeah.
Okay.
73.
So,
I got positive 39. I guess they did okay.
CompuDo's. So let's see if that makes sense according to what we've got right here, okay? Let me paste it. So, does it look like that is a positive 68 and a positive 39? Then it's at least in the right quadrant, right? Okay, so I'm going to fast forward through these slides, and we're going to see what they did. Okay, so we find the x and y components of each vector. We did that.
Does that mean they used the big ones? No.
Okay. Whoa, I don't know what's off last year. Okay, that's freaking me out. Anyway, and they're doing all the mapping there. Where's my final answer?
I did the
Oh,
thing.
full, it says. Okay. 77.9 for their resulting. Okay. Oh, they went ahead and found the angle. We didn't find the angle. Oh, we also didn't figure out what our final distance was. So let's solve that real quick. Okay. If that's our vector, then let's figure out how long it would be. How snot are we going to do that? Actually, I may be having us bite off too much for the first day. Let's maybe call it here for today.
We can handle it.
You won't call it.
I'm fine calling it here for today.
We're all juniors and seniors.
Oh, I know. I'm not doubting your abilities. I'm just saying I think that's plenty enough to mull over before we try and move on. Great place for questions. Anybody got some? Like, where's the door? Oh, it's clearly marked exit. Okay.